Hello everyone, and welcome to our Arrays module. Over the course of these upcoming sessions, we'll be taking a deep dive into one of the most fundamental data structures in programming, the array. We're going to explore not only how arrays work, but also a variety of advanced techniques and operations that will help you become more efficient in solving real-world problems. Here's a quick overview of what you can expect. Introduction to arrays. We'll start by defining what an array is and why it's such a crucial building block in most programming languages. Fixed size versus dynamic arrays. Next, we'll compare different types of arrays, looking at their memory usage, flexibility, and performance implications. Time complexity of arrays. We'll discuss how to evaluate and optimize the performance of array operations, ensuring you can make informed decisions in your code. Array operations: insert, delete, update. We'll dive into common operations, where to insert, how to delete efficiently, and the best ways to update elements. Multidimensional arrays. Moving beyond the basics, we'll explore arrays with more than one dimension, like 2D arrays for matrix operations. Next, we will look into memory layout of arrays. Here, we'll delve into how arrays are stored in memory, the concept of contiguous allocation, and how that affects performance and indexing. Searching in arrays: linear search, binary search. We'll walk through the two most common search techniques, explaining when and how to use each one effectively. Merging arrays. You'll learn how to combine multiple arrays into one, a key step in many sorting and data processing algorithms. Rotating arrays. We'll look at different methods for rotating arrays and discuss scenarios where array rotation is especially useful. Finding the maximum subarray sum, Cadon's algorithm. This classic problem illustrates how arrays can be leveraged to solve optimization challenges efficiently. Sliding window technique. A powerful approach for solving a range of subarray-based problems, from maximum sums to substring analysis. Two pointers technique. We'll cover how to use two pointers effectively to simplify array traversals, partitioning, and searching tasks. By the end of this module, you'll have a well-rounded understanding of arrays and be able to tackle a variety of problems using these techniques. Whether you're new to programming or looking to refine your existing skills, these sessions will provide the insights you need to handle arrays with confidence and efficiency. I'm excited to get started and look forward to exploring each of these topics with you. So on this note, I am stopping over here. See you in the next session.